Here we have half-life problem for exponential modeling. So this one says if 250 milligrams of a radioactive element decays to 200 milligrams in 48 hours, find the half-life. So let's look at the half-life formula. It's not super important what variables you use, I guess, but the basic formula, we'll just use M and then equals M0. We'll use this for the initial amount half-life, so we can use 1/2 here, and then to the whatever variables you want. So we'll use T and R. So here M will be the ending amount. We'll let M not be the initial amount. We'll let R be the half-life. And then we'll let T be the time, however long this element has been decaying. So R is a constant. T would be the input variable. Um, and so what are we looking for? We're looking for the half-life. So we're looking for R. And so we should be able to find all of the other variables in the problem here. So we have 250 and we have 200. So which one would be the initial amount? Well, if we have a decaying element, we have a half-life, we're going to start with a bigger amount and then go down to a smaller amount. It's decaying, so the amount is getting smaller as we go. So that tells us that M would be 200. So we're going to set up this equation. We'll have 200. 250 would be the initial amount times 1/2. Uh, R is what we're looking for. So that means that T is however long this has been decaying in hours in this case. Doesn't have to be hours in every problem, but whatever makes the most sense. And you want to be consistent. So if the T is going to be in hours, then the R is also going to be in hours. Um, So T is going to be 48 and then over R. And so we need to solve this equation for R. And so the first step would be to get the exponential part of this equation by itself. And so the first step would be to divide both sides by 250. So 200 divided by 250, that's 0.8. That's going to equal 1/2 to the 48 over R. Now we have the exponential part of this by itself. So now we can take the logarithm of both sides, and you can do however you want. You can take the ln of both sides, or you can take the log of base 1/2 both sides. Either way will do the same thing. So let's do log. We'll do log base 1/2 on both sides. Log base 1/2. 1/2 to the 48 over R. I think this way is a little bit easier. It eliminates one or two steps. So then we can plug that into the calculator. And if you don't know how to do that, if your calculator doesn't do just any base, you can put in log of 0.8 and then divided by log of 1/2. Or you can do ln of 0.8, ln of 1/2. It doesn't matter as long as you do the same thing. And so when you put that in the calculator, you're going to get an irrational number. Whenever you have an irrational number in a calculation, you're going to want to, if possible, as you go, don't retype the number into the calculator. But at the very least, you want to keep 6 digits or more. 6 digits should be fine. So we get 0.321928 for that. On this side, the ln 1/2 and the 1/2 cancel each other out, and so we just have 48 over R. Now it's a pretty simple equation to look at. Let's cross multiply. We get 0.321928 times R equals 48. And then, of course, we'll divide both sides by that number. And so we get 149.1 or something, but I think the textbook asks to just round to the nearest hour. So 149 hours. And so sometimes, whenever you can, it's usually a good idea to see if your answer makes sense. So in this case, we know that this element goes from 250 down to 200 in 48 hours. So it's not gotten to the half-life. So if it went from, we're essentially wanting, how long does it take to go from 250 to 125? So since it has not gotten down to 125 yet in 48 hours, the half-life must be more than that because it hasn't got to half yet. And so it still has more to go. So obviously it's going to take more time to go from 250 to half of that. So whatever you get here, obviously you think about it, it's got to be positive, but we also know it's got to be more than 48 hours. And so if you do this and you get an answer that is less than 48 hours, then you must have done something wrong because in less than 48 hours, like if you get 35 hours, it would have gone from 250 to 200 something. It would not have gotten to 200 yet, and so obviously it would not have gotten to 125. So things like that, think about. The other thing you might see problems that ask for the doubling time. In that case, you basically set up the same formula, but you'd use a two instead of the one half. Or you could, in this case, write 2 and then to the negative r over 48. That would do the same thing. So you kind of want to get familiar with um, seeing how these things relate, thinking about what your answer should look like. Obviously, you're not going to, no one can just look at this and tell what the answer is 149. That's not the point. But you do want to be able to know if your answer makes sense. Like, if you get a ridiculous answer, you should recognize that in a lot of cases. So hopefully that will help.